Okay. Now we will get into one of the most important topic, never heard or less heard prior to 2004, at least in this part of the world. We call it as nature's fury, that is nothing but tsunami 2004, and it is also very often referred to as the Great Indian Ocean Tsunami. So, for the benefit of most of you, many of the informations which I am providing are available in the net, and as this is quite useful to general audience, so I have taken the liberty of using informations from different sources, be it newspapers, magazines, informations from friends, students, faculty colleagues, internet, different websites, etc. So, finally, I will place on record thanks at the end of the lecture. So, organization of the lecture: waves, tides, current and tsunami. Tsunami definition, its travel, past events. Cyclone, wave and tsunami, what is the difference? Warning systems, then some of the safety rules, and based on imageries I will give some information. The different phenomena: what is a wave, what is a storm surge, what is a tidal wave, what is a tsunami. Here the wave is an oscillatory motion, and it is driven by the speed of the wind. Wind is acting over the water surface, generates waves in somewhere in the deep ocean, and then you have the waves generated and it propagates, and then it breaks, and then you have a gentle uprush over the beach. This is a everyday phenomena, and you are very sure that no extreme event is going to happen. If there is an extreme event happens, like the one you see there, if there is a low pressure built up in the Bay of Bengal, for example, then it is possible for the meteorological department to monitor the movement of the low pressure area and then give you periodic signals or warnings saying that you are likely to have a cyclone. Cyclone is associated with heavy wind speeds, and you have a very clear warning that a cyclone is going to hit the coast. And storm surge is also similar case, wherein you have the low pressure areas and you can have a storm, and there can be also extreme surge taking place near the coastal belt, coastal area. So, during storm surge you can have water levels going up to about 10 meters. We have had enough number of storm surges along the east coast, particularly along the east coast. Tidal wave is again, it is between the attraction between the celestial bodies, and it is quite a huge wave which can rise up to several meters. But what is a tsunami? Tsunami is, you have this, but the water level goes up, and the original beach is here, and when the water level goes up you see the waves running over. What are the causes for? So, you see that there is no question of a kind of, you can have a kind of preparedness for this kind of a event. because the height of the tsunami can go even up to about 30 meters. And if you want to have some kind of a barrier for a tsunami, and when the tsunami height can be as high as 30 meters, you cannot raise a wall against yourself. So what are the problems? First, what are the causes? Now this is the basic difference between waves, storm surge, tides and tsunami. More about the details, I have given the complete description about the mechanics of ocean waves in my lecture under wave hydrodynamics. Now here is some of the information. Storm surge and tsunami, which is more closely related. In this case you have a low pressure, converging winds raise sea levels under a cyclone. During a cyclonic activity, the sea level rise near the coast as a surge over which powerful wind waves propagate. We have a clear warning, but effect is almost same, but it is not so devastating as in the case of a tsunami. Tsunami is something like a wall of water, it is just a wall of water surging into the coastal land. Destructive power accelerates while it recedes immediately after inundation, because in this picture your original shoreline was somewhere here. Now you have the rise in sea level, I mean the water level, and then it has propagated. It has propagated. For example, it has propagated like this, and it can propagate maybe for 1 kilometer or 2 kilometers. It depends on the kind of land over which it is propagating. But then the gradient is actually back to the ocean, so this comes back. So much of mass of water coming back, that has tremendous destructive power. So most of the destruction took place when it was returning back. And in this case there is absolutely no initial warning, so it can happen anytime. So causes for tsunami, that is natural causes. Natural causes of tsunami are due to an earthquake, due to landslides, due to volcanic eruption inside the ocean. So you inside the ocean you see the seabed, and beneath the seabed it is all like plates which we will be seeing. So you have something like land, something like rock material, and if you have a huge landslide inside the ocean, the entire water medium gets disturbed. And similarly, if you assume that some of these structures beneath the ocean, if they move one below the other, then you might have a tsunami being caused. So either an earthquake or a landslide or a volcanic eruption, these are the main causes for the now you see the wind waves come and go without flooding higher areas. If there are some there may be some extreme events in the waves also, there may be some local phenomena. A local phenomena can occur where you can have an extreme flooding locally for a short duration, but tsunami is not like that, it runs quickly over the land as a wall of water. Now zonation based on Now we look at the zonation based on the behavior of ocean waves. Waves enter the shallow waters, waves touching the bottom, wavelength shortens from waves move in from deep waters, constant wavelength. So this is how it moves. Then when it is about 0.5 times the wavelength, you see that the steepening of the waves take place, and somewhere around this place the waves breaks when it is approximately 1.3 times the wave height, and then you see the gentle uprush of the water. So the physics of the behavior of ocean waves is well understood. Now we move on to a tsunami. A tsunami is a series of waves, or is termed as giant waves, with wavelengths of few kilometers and period 10 minutes to 2 hours, that results in from displacements caused by large earthquakes, that is vertical movements. This is very important. Major submarine slides or exploding volcanic islands. So one thing very important aspect is that when you have a wave, tsunami is also a wave. When you have a wave, you see that this is wavelength, and time taken for moving traveling for the wave to travel one wavelength is the wave period. So this wave period in the case of a wave is mostly less than 30 seconds. Most of the time it would vary between 5 to say 15 seconds. Occasionally you will have a period greater than 15 seconds, and the wavelength is only of the order of meters. So for example, if I have a wave period of 10 seconds, what is the wavelength in a water depth of, in a depth of say 1000 meters? One L naught is equal to 1.56 into t square. Okay, so how much it is? 156 meters. Is that clear? But in the case of a tsunami, it will not be in terms of meters, it will be in terms of kilometers. So tsunamis are often incorrectly called as tidal waves. The speed of the tsunami is about 8,000 kilometers, it can be about 8,000 kilometers, 800 kilometers per hour, that is equivalent to that of a jumbo jet. And in open sea, its height is only about 1 meter, and it is hardly felt. So during a tsunami, if you are in deep waters, better remain in deep water, do not come to the coast. And when it reaches the coast, it can go up to about 30 meters, and it can weigh, its weight can be millions of tons. 2004 giant tsunami is said to be 4.75 lakh kilonewtons, that is 23,000 times the energy that was released by the atomic bomb that destroyed the entire Hiroshima. It propagates radially, anywhere it propagates radially, and it can travel for hundreds and hundreds of kilometers without any problem. Basically it is a shallow water wave in deep waters. particularly this tsunami. What does that mean, shallow water wave? So, as per the wave mechanics, when d by L is greater than 0.05, you have the disturbance of the felt only up to a distance which is L naught by 2, and L naught is only in terms of meters. So, when a wave is propagating, the effect on the seabed is not felt at all. Say for the instance, for example, if the water depth is greater than 1000 meters, it is not felt at all. But in the case of a tsunami, water will be felt because here d by L is less than 0.05, because water depth is, although it is greater, the wavelength is in terms of kilometers. So, hence this will be felt, the effect of waves will be felt all the way up to the water depth, even if the water depth is 4000 meters. So, that is the major difference. How fast does a tsunami travel? Since it is behaving as a shallow water, the speed of a shallow water is given by root of GD. So, which comes to around 8000 kilometers or 700 kilometers in the case of 4 kilometers water depth. When I say 4 kilometers water depth, I am referring to the Indian Ocean Indian Ocean tsunami of 2004, that occurred in a water depth of 4 kilometers. Is that clear? And that is why I am using that 4 kilometers of water. So, the speed of the wave is 700 kilometers per hour, then you can imagine how it would have travelled. Tsunami in the history. You have a lot of information in this slide. So, 2004 people killed are around 280,000. So, if you look at the whole history, this is the worst. This was the one of the worst tsunami, and that is the reason why I chose to talk about this tsunami, what were the effects, etc. Few facts of the past events. 90 tsunamis have been recorded in the Pacific since 1900, major once in a decade. Alaska in March 1964 and in Chile in 1960 travelled 17,000 kilometers to Japan. That is Chile, you know where it is, South America. So, it has travelled all the way to Japan over a distance of 17,000 kilometers. The 2004 Great Tsunami will be discussed in this lecture. Before that, a few facts of the past events again. The 2011 off the Pacific coast Tohoku earthquake, that is on the Richter, it was 9, that occurred on March 11th 2011 at 2:46 p.m. Japanese standard time, with an epicenter at the latitude and longitude are given. A mega tsunami was generated by the earthquake, causing devastating damage to the Japanese Pacific coast from Tohoku district to Kanto district. A lot of informations are available about this tsunami in the net, and this was also really very devastating. After the Indian Ocean tsunami, this was again a major tsunami. Tsunami also travelled to Tokyo Bay approximately 350 kilometers from the epicenter and damaged part of the coast in the bay. Tsunamis are not entirely unknown in Sri Lanka or India. We had forgotten about tsunami prior to 2004. For example, the tsunami that occurred in 1883 generated by volcanoes at Krakatoa Islands, that led to a surge of at least 1 meter in Sri Lanka, but the damage was not that much. Tsunami is recorded in India. 1883 explosion of Krakatoa volcano, that is again in Indonesia. East coast of India was affected, 2 meters of tsunamis were recorded in Chennai. 1941 on a Richter of 8.1 earthquake in Andamans. East coast of India was affected, but no estimates of the tsunami heights is available. Then 1945 on a Richter of 8.5 earthquake at a distance of about 100 kilometers south of Karachi, that is we are referring to Arabian Sea. West coast of India, most from north to Karwar, north of Karwar was affected. So 12 meters tsunami was felt at Kandla, 12 meters of tsunami. So Andaman and Nicobar Islands since 73, a dozen of earthquakes in its vicinity, but mostly ranging between 5 to 6 on the Richter. So this Richter, even 0.1 really matters in terms of devastation. So in fact ours in the case of ocean our 2004 tsunami, it was initially said the strength was 8.9, later it was fixed as 9.3. Every single decimal point really matters when you look at its strength. Before we go into the tsunami, because tsunami due to the earthquake is happening below the earth. So let us look at, I will not go into the details, but if you are interested you can go into all the details of the tectonic plate movements, etc. The surface of the earth is made of a patchwork of massive rigid tectonic plates. It's all something like plates, that is the surface of the earth, of about 80 kilometers thick, which floats in slow motion. You do not feel that, on top of the earth's hot flexible interior. These plates change in shape, change in size and position over time. So when you, this is what is called as a ring of fire. These are all some of the background material. This is a ring of fire. So you see that this is Australia and this is where we are, this is the location which we are talking about. So circling the Pacific Ocean on the bottom of the seabed lies a series of volcanic arcs and deep ocean trenches called as ring of fire, and this region has a highest occurrence of earthquakes and volcanoes. This region is called as Circum-Pacific seismic belt, is a source to over 75% of world's active and dormant volcanoes. That is about volcanoes. Now when we look at the movement of the continental plates, you look at all these continents, it is believed that millions and millions years back all the continents were together, and then as years rolled on they started splitting from one another. Now when you look at this thing, if you put everything, if you remove everything and put it together, you can get a single piece. So exactly you see that India will just go and slip into that. and wherever you have islands, those are the places where you have possibilities of earthquakes. For example, Andaman, Indonesia, Japan, and you go into Hawaiian Islands. So, I said about the Chile tsunami, you see that Chile is somewhere here, a tsunami that was generated here moved all the way to Japan. It has travelled about 17,000 kilometers. This is the animation which you saw is based on a numerical simulation. And after the tsunami of 2004, this has become a very interesting area wherein so many institutes are involved in the numerical simulation. Why this numerical simulation is important? Because when you know that there is a fault, because you can easily say this is the area where you can have there is a possibility of having a earthquake. Indonesia is prone for earthquakes. We know that this is the area where you are likely to have earthquakes. A earthquake of different intensities. So, as an exercise I can simulate and a strength of the exact characteristics or more or less exact characteristics of the earthquake that has occurred during the 2004 tsunami, and then allow the waves, the disturbance felt on the surface of the ocean, and then allow the waves to propagate, and then check what are all the areas that are likely to get inundated. Not only that, you can also find out the time of arrival. Suppose if it has occurred in some say 2 p.m., how much time it will take to reach India along Chennai or along Kerala? Will it ever reach Kerala? Something happens in Andaman area. Is there any possibility for you to see some its effect somewhere near Kerala, or will it be felt even near Bangalore, sorry not Bangalore, along the Karnataka coast? Certainly it will have its effect along the east coast because it is directly opened. So, you can have, once you have simulated a numerical model, you can keep on trying with different kinds of scenario. Instead of a Richter scale of 8.9, if I have a Richter scale, I just increase it to 8.95 or maybe 9, you will see the difference in the pattern of inundation. So, this is a kind of a mock-up exercise to also get yourself prepared, you understand. So, such simulations are very important. Now, you look at this, this is the Karakutu island that occurred in 1883, that is in Japan, where this was an volcano eruption. So, you see that it has travelled, it will slowly travel all the way to Sri Lanka. So, when you, if you have a numerical simulation that shows this, you can this helps you in preparing the vulnerability map or the inundation map or preparedness map or whatever you would like to call. Okay. So, when you talk about a tsunami, the tsunami happens somewhere here, a earthquake. So, if there are plates which are in compression beneath the seabed, and when they are disturbed during the earthquake, the plates move either this way or this way or this way. When there is a movement of the plates, naturally it is something like a wave maker, you know. So, it disturbs, so much of energy is released into the fluid medium. So, when it is released into the fluid medium, you will have the source, at the source the disturbance of the displacement of the water surface. So, the displacement of the water surface will take place here. then you have the radial motion, and then you have the propagation, and then you have the inundation, because the waves are not going to break. So, if you assume that this stretch of the land is not like this, then you do not have much of a fear, but you assume that your beach is a flat one, something like this, something like a if you are living along a coast where the beach slope is flat, under normal wave action you are not going to have any problems. But in the case of a tsunami, you see that submergence of the entire area can take place. That is why flat beaches are good for beaches, for recreation, but very dangerous in the case of a tsunami. So, what we need to do is, in the case of numerical modeling, numerical modelers try to work on how to truly represent the source term at this location. That is, how do you represent the disturbance, how big is the disturbance, the magnitude of the disturbance is very difficult to define. Once that is defined, and once the disturbance at this location is established, then we have a number of numerical models which can take care of the propagation and also the inundation. Once this information is known, you can make your plans for the mitigation measures. So, when you look at the plates in the ocean, you see that this is the Indian plate, this is the Australian plate, and this is the Pacific plate, and here the Burma plate, Eurasian plate is here, and this is actually the Burma plate. So, you have a lot of plates beneath the ocean surface, beneath the seabed, where there are boundaries which are like these plates are in compression, it is sticking very close to each other. Like here, if you see, these are all converging boundaries, they are under great tension. If one plate slips over the other plate, so this is one plate and this is another plate, suppose this plate moves below, then it results in the earthquake and you have the possibility of generation of the tsunami. So, what we will have, we need to see is this Eurasian plate or the Indian plate which slipped, which went below the Eurasian plate or Burma micro plate, this is Burma micro plate, and the whole thing is the Eurasian plate. This is exactly where you had the problem of this plate going below the other plate. Why did the occurrence of 2004 tsunami take place? The earthquakes occur when any of the plates collide at their boundaries. Scientists believe that one plate that comprised the landmass from India to Australia, okay, has broken into two parts, and the initial eruption was 8.9, happened near the location of the meeting point of the Australian Indian plate, that is this plate, and this is the Burma plate. So, this is the point. Scientists have shown that this is a region of compression, as the Australian plate is rotating counterclockwise into the Indian plate. Tsunami originated in the subduction zone, that is in between the Indian plate and the Burma plate. So, tsunami originated in the subduction zone, over a length of 1200 kilometers, width of 100 kilometers, and over a depth of 20 kilometers, 20 meters, sorry. So, the types of movements of the plates are shown here. You have a normal, that is, one is going out, the other is a strike. Strike is the lateral movement, okay, and oblique is like this, and then you have the thrust. So, when you have one plate subduction taking place over the other, then you see energy is released from the ocean surface, from the bottom, and then the waves start moving in radial directions. So, once they start moving in the radial direction, it will move, keep on moving, and it will bring lot of problems to the coast. So, that is in plan. Now, if you look at this, you see that the eruption has taken place here, and then you see the waves slowly moving, very fast moving, and then it reaches, you look at the amplitude of the waves, it magnifies when it comes to the very close to the coast. So, these two animations show you how these tsunamis are generated, and tsunami due to subduction of plates. So, this is where you have the subduction taking place, one moving below the other, and then the water column pushing up, and then you have the shallow waters and the building up of the waves, I mean the energy, and then the propagation of the tsunami into the land. So, movement, this is what happened in the case of this location, this was the area where it happened. So, this is the Indian plate, this is the Indian plate, and this is the Burma microplate, and now this is trying to move, as we have seen in the other animation what happened. So, when it moves, you have sudden release of. So, once there is an earthquake like this, there can be a number of shocks at very short intervals. And once a wave is, once this kind of a incident happens, you can have a tsunami in the morning, and again in the evening you can have another wave, giant wave coming. So, but this being the case, 12th April, very recently you would have heard about the tsunami, I mean earthquake. So, there was a warning given, that was on April 12th, the initial, and today is 15th April, today is 3 days back. The initial earthquake struck at a depth of 22 kilometers with an epicenter of 430 kilometers southwest of Bandarache. So, Bandarache is the location where the 2004 tsunami also occurred. So, the magnitude of the earthquake was initially arrived at 8.9, almost the same as that we had in 2004. Then later it has been corrected to a magnitude of 8.7, whereas in 2004 it was 9.3, later corrected, and the time of occurrence was at 2:30 IST, whereas 2004 it was in the morning. The earthquake which occurred on April is of type strikes, so it is only a lateral movement. So, lateral movement of these plates will not cause any earthquakes, any tsunami. So, there was absolutely no tsunami and no fear and no damage. There was an initial warning given and then taken away by evening. So, this explains why the April 12th tsunami, I mean earthquake did not cause any tsunami. Now, we go back to 2004 tsunami. So, it occurred, the epicenter was 42 kilometers in Indonesia, and the time of arrival is time of occurrence is given there, the latitude and longitude, and the depth 10 kilometers below the surface of the sea. Then you had the magnitude, but the water depth is 4 kilometers. then initially on the Richter was 8.9, and then the countries affected are India, Sri Lanka, Malaysia, Indonesia, Bangladesh, Somalia. So, in the case of a tsunami, only post-mortem is really possible. Preparedness, okay, you can prepare yourself for the tsunami, but only what has gone wrong, but post-mortem really helps. So, this is the seismograph taken at 1:20 am on December 25th, and this is the seismograph after the catastrophe has taken place. You look at the disturbance taken place through the seismograph. Initial warning before a tsunami, the sea will recede from the coast, exposing a part of the seabed. If the slope is shallow, this recession can exceed 800 meters or even a kilometer. People unaware of the danger may stay at the shore due to curiosity, but this may be a warning sign of a coming tsunami. Relative size of a human being with that of a tsunami. So, what happened during the tsunami is, many of the people, being a Sunday, they were near the beach, and when the water level receded, that is, when you saw the water going into the ocean, people thought, because we have never heard of tsunami for so many decades, suddenly you see the major portion of the seabed getting exposed. So, out of curiosity, people went onto the seabed, just looked at the fish catch and other things, and then not realizing that that is going to be their tragic end, and many people lost their life due to that. So, initial warning, this is how it looks, the retrieving of the water level, and then you see the approach of the giant waves. You can have 2 or 3 in series attacking the coast, not leaving much of time for you to escape. So, this as I said, post-mortem is very useful. So, shoreline receding in Sri Lanka during the, so you see just coastal areas like Sri Lanka as seen in the satellite. Now, so almost no warning of approaching tsunami, it was looking like a normal stuff, but prior to the tsunami, you see what happened, greater portion of the sea beach was exposed, and you see on the bottommost, tsunami has attacked the coast, and you can find out how much of distance, how much distances are gone inside the land, and what could be the sun, that these things, this how high it has gone, you need to verify with the local signature studies. You need to do the survey and find out how much height tsunami you had at different locations. So, this is another picture at some other location, where it shows that the retrieving has taken place about receding has taken place about 350 meters. This is showing the flooding areas. So, when you look at this tsunami wave, this has occurred in around 4,000 meters. At that point of time, it was around 213 kilometers of the wavelength, and then this shows the reduction in the wavelength as it propagates towards the coast, and wherein the height is also shown here, and along with the so these are the heights, these are the depths, the velocities are shown here, and your wavelengths are given here. So, this gives you an impression concerning the speed, wavelength, depth, etc., and how it behaves in the deep waters as well as in the shallow waters. So, tsunami travel, it has taken about 2 hours to reach Calcutta, to Kerala. So, for example, it reached Chennai, the west coast, east coast of India, about that is 60 minutes earlier, about 50 minutes earlier, but it took not more than 10 minutes when you compare from this location of Sri Lanka and Chennai. just 10 minutes, but we had something like 50 minutes, but we were not really knowing that it is going to have its effect along the India Kerala coast, but now we know why it has affected the Kerala coast also, we are very clear about that. See, for example, this was the first animation that was available on the net prepared by the NOAA. So you see that at this particular location, once it hits Sri Lanka, you have the diffraction of waves taking place, and it goes, and this mainly because of the diffraction. This is the area which was not affected at all because it is under the shelter of Sri Lanka. The major area that was affected is all the way from here to here, the south, all this area, and you did have some problems along the Andhra coast also, but not much, but this area was very badly affected. So we had at that point of time we had a lot of discussion with particularly by a team from University of Oregon State University from US, as well as there is another university from Seoul, one Professor Choi was there, and he is a specialist in tsunami mitigation measures. So we had a group joining together, and we have done a lot of signature studies immediately after the tsunami to find out how much distance it has gone, how high it has gone, etc. And this paper is available in the Journal of Waterways Ocean Engineering Division of AICE. So if you are interested, you can just have a look at it. So this was the animation given by Professor Choi from Sungkyuan University of Korea, wherein this shows how what are all the countries that were affected. So the tsunami has travelled even to Australia, Madagascar. So it did have some effect all over. The entire basin was really disturbed. I will stop.